Good morning. Rogani College of Engineering and Technology, aggregated with A plus grade by NAG, Department of Civil Engineering, C3402, Strength of Materials, Regulation 2021, A. Anand, Assistant Professor, Department of Civil Engineering. So today we're going to see the topic deflection of beams, elastic curve or deflected shape. The curved shape of the longitudinal centroidal surface of the beam due to transverse load is known as elastic curve. So this is the diagram. In a beam, simply supported beam, there is action of a point load at center. So the beam get deflect by these conditions, elastic curve. And two ends there is theta, slopes. Okay, and at center there will be a deflection. And deflected shapes or elastic curves are of beams with different supports conditions. So cantilever beam, simply supported beam, continuous beams, fixed beams, and propped cantilever beams. So these are the elastic curve forming in different beams. Next, slope. Slope is an angle formed by the tangent drawn at the elastic curve to the original axis of the beam. Deflection. Deflection is the translational movement of the beam from its original positions. And deflection and slope of the beam subjected to uniformly bending moment. So here the conditions. A beam AB of length L is subjected to a uniform bending moment M as shown in figure. As the beam is subjected to constant bending moment, hence it will be bent into a circular arc. The initial position of the beam is shown by ACB, whereas the deflected position is shown by ACB. So this is the elastic curve, the circle L by 2 and L by 2 in a beam. R is equal to radius of curvature of the deflected beam. Y is deflection of the beam at the center. I is equal to moment of inertia of the beam section. So the reactions between the slope, deflection and radius of curvature are derivation and differential equations. So let the curve AB represents the deflection of the beam shown in figure. Considering a small position PQ of this beam, let the tangential at P and Q make angle pi with the axis normal P and Q will meet at C such that this is the point C is known as the center of gravity of the curvature of the curve PQ. Let the length of PQ is equal to ds. So this is the image. PC is equal to QC is equal to R. And this is the conditions EI into d square y by ds square. By using this conditions, you want to find the final conditions. For deflection is equal to y, slope is equal to dy by dx, and shear bending moment is equal to EI into d square y by dx square. Shear force is equal to EI into d square y by ds square. The rating of loading is equal to EI into d square y by ds square. So these are the derivations applied in this deflection of beams. Thank you.